Okay, guys, for the third and last time, I'm back at this preparing for the ACT test that's been out for a few years now. But today, what I want to do is go through the final 20 problems in this math test. And actually, at the time of this recording, the ACT just put out their first ever practice test for what they're calling the new ACT. So by the time you're watching this, you might have already, this old ACT test, this format might be in the dustpan. But I will say these 20 final math problems are very indicative of the kinds of math problems that you're going to see in the new format. The reason I say that is because I noticed that when I took this new format ACT test, what I'm talking about here is this new 45 question math test where you have 50 minutes. I noticed that a lot of these problems are very difficult and a lot of them are designed to be time consuming. And so I think it's really important to, come to a greater understanding of these final 20 problems in this test, because I think that that's really going to help us prepare for this new format ACT test, which unfortunately, just because it's smaller doesn't mean it's easier. So that being said, let's get into number 41. Okay, number 41. The equation 24x squared plus 2x equals 15 has two solutions. What's the greater of the two solutions? Okay, so my explanation of this problem is going to take me a little while because I'm going to go through the two different ways that I can think of that would be fastest to solve this problem. And there might be some others, like if you happen to have the quadratic formula memorized. Again, I don't think that's necessary for the ACT, but if you happen to and you wanted to plug that in, that would be fine. You can find the two solutions there to this quadratic, but I don't think that's necessary. So for me, my initial instinct is this. Okay, well, here we have 5 proposed options. Let's use back solving to solve this. So this is saying that there's 2 solutions to this equation, which is going to be true. So if you were to graph this, we'll talk about that more in a second, you're going to get a parabola. It's going to be shaped like this. And the 2 places where it crosses the x-axis are going to be its 2 solutions. So in other words, kind of taking a step back, if I plug in these answer choices one at a time and one of them, you see how clumsy I am, and one of them satisfies, then that means it's going to be a solution. So here's what I mean by that. If I take 3/4 and I plug it in for x into this equation, anywhere I find an x, and I get something on the left that equals 15 and on the right it equals 15, then guess what? That's going to be a solution because it satisfies. So let's try that out. Okay, so if I go to my calculator and I type in 24 times 3/4 squared plus 2 times 3/4, again, I'm just going to put 0.75 in the calculator instead of 3/4. What do I get? So writing this out on paper before I actually, do it on my calculator, it would look like this: 24 times 0.75 squared plus 2 times 0.75. The question is, does that equal 15? Because if it does, since equals 15 is on the right-hand side, that means it satisfies. So let's see my calculator: 0.75 squared equals times 24 equals plus 2 times 0.75 equals, sure enough, that equals 15. Okay? So again, I just put all this in my calculator, that equals 15. And guess what? When I plug in 3/4 for x, I get 15 equals 15. That means it satisfies. Okay? The problem is this question is saying, what's the greatest of the 2 solutions for this parabola? Okay, and that's a little bit trickier because we have more options that are bigger than 3/4. So we know 3/4 is an option. So we can only eliminate other answer choices that are smaller than 3/4. And unfortunately, out of these options, there's only one that's smaller, and that's E. 11/15 is just a little bit smaller than 3/4. So we'll just have to go through the other 3, plugging in 4/3, 5/6, 7/6 in there for x squared, and see if we end up getting something that's equal to 15. And I can already tell with 5/6 and 7/6 and 4/3 that those numbers are not nearly as clean as like 3/4 and 4/3. And so when I square them and multiply them by 24, I'm not going to get an even kind of a number that ends in 0.00, like it's got no decimals after it. I can already tell that. So for me, I would probably already say, okay, A is going to be the right answer here. But let's go ahead and give C and D a shot. So 5 divided by 6, 5, 6. Yeah, that's 0.833 repeating. I can tell this isn't going to be the right answer, but I'm going to go ahead and put 5, 6 in the calculator so I can show you what I'm talking about. Because when you divide a number by 6 like that, unless it's an even number or like 3 where you get 1/2, I'm going to get some repeating decimals. Okay, so 5, 6 is the equivalent to 0.8333 on repeating. Okay, well, let's square that. Let's multiply that by 24. Let's add that to 2 times 0.833333. And that gives me, sure enough, 18.33 and on and on and on, or whatever. Okay, it's not 15. And I can tell it's not going to be the same thing with D. Like I'm going to get the same thing, a bunch of repeating 3s that when I square it and then multiply by 2 and add it, it's not going to equal 15. I can already tell. So that's one reason I know the answer is A, plugging in the options and seeing which ones satisfy. A second option is to use your graphing calculator. Okay, this is one of the areas where having a graphing calculator compared to a scientific one is a major benefit. Okay, to graph this on a graphing calculator, on the top left-hand corner, you hit y equals. Okay, that's the first button you hit. Then you're going to type in 24. Sorry, this is its own button. So y equals 24. Then there's a button that looks like this. It's x, t, theta, n. You would hit that button because that pops up an x. Then you hit the x squared button, right, to put a squared up there. And then you would hit, of course, plus 2. And then you hit this x, t, theta, n button again. And then minus 15. Okay, if you put all that in your graphing calculator, y equals 24, the x button, the x squared button, right, because that's 24x squared plus 2 times that x minus 15. And then in the top right-hand corner, you see a button that says graph, okay? And then if you go ahead and do that, hit graph on there, you're going to get a graph that pops up that looks something like this. Let me kind of zoom in to make it bigger. You're going to have the XY coordinate plane, okay, like this. You're going to have, here's 1 and 1, so x equals 1 equals negative 1. Here's y, 1, x, whatever. And then you're going to have a parabola pop up that does this. It goes way down. You can't see probably way down here if you're zoomed in at all, and then it comes way up right here. Okay, it's going to look something like this. And if you hover your cursor over this point right here, you're going to see that it's equal to 0.75. Okay, the bigger of the two solutions. You see, 3/4 or 0.75. That's why number 41 is A. Number 42, which of the following expressions is equal to sine of 60 times the cosine of 30 plus the cosine of 60 times the sine of 30? And what the ACT is expecting here is that students are going to see these expressions being multiplied, and they're going to think, I've never seen that before. Maybe like my cousin who was in trig, like he had to do that, and that's scary. Okay, it's really not that scary. They're not expecting you to have memorized what this reduces down to. Okay, if you want to know the sine of 2x times the cosine of x, right, if x is 30 degrees, plus the cosine of 2x times the sine of x, that's equivalent to the sine of 3x, okay? So if you want to know that, that's what's going on here. But you don't need to know that, again, and actually, I think that it would be kind of a waste of time to try to memorize that stuff. Instead, put all this in your calculator and get a number, right, guys? So if you put in your calculator sine of 60, hit enter, times cosine of 30, hit enter, plus, and then maybe in parentheses, the cosine of 60 times the sine of 30, and it equals, sure enough, this whole thing, when you put it in your calculator, equals 1.00. It equals 1. So then all you have to do is back solve now. Go through these options and see which one equals 1. Okay. I already know off the top of my head that the sine of 90 equals 1, and the cosine of 0 equals 1. Cosine of 30, which is this right here, does not equal 1. The cosine of 90 right here, that equals 0. I'm going to put it in my calculator just in case. Cosine of 90, yeah, that equals 0. It doesn't equal 1, so it's not that. Sine of 30 does not equal 1. I know that off the top of my head. If you want to put that in your calculator and figure it out, you can. But then look at J. It says the sine of 60 plus 30, in other words, the sine of 90. And sure enough, I know for a fact that that also equals 1. That's on number 42 is J. 43. What is the area in square units of a circle that has a circumference 12 pi units long? Okay, to find the area of a circle, you need the radius. And you can go from the circumference to the radius, no problem. So let's go over these two equations of a circle that you have to know. First, the area of a circle. The area of a circle is pi r squared. That's why I said you need the radius. The circumference of a circle, which is just the distance around the outside, like the perimeter, that's 2 pi r. Okay, so here we know the circumference is 12 pi. That equals 2 pi r, right? So you can see from here we're going to find the radius, right? So pi is going to cancel. 12 divided by 2, right? Divide that by 2, of course, that cancels. And you get that the radius equals 6. That's enough for us to figure out the area of this circle because the area is pi r squared. Well, r squared is 36. Fortunately for us, the answer choices over here are all in terms of pi that will multiply through pi, so that's a step we don't need to take. So if the radius squared is 36, That means the area is 36 pi. That's how I know 43 is D. 44. A barrel contains 25 liters of a solvent mixture that is 40% solvent and 60% water. Lee will add pure solvent to the barrel without removing any of the mixture currently in the barrel, so that the new mixture will contain 50% solvent and 50% water. How many liters of pure solvent should Lee add to create this new mixture? Okay, the first thing I want to do is figure out how much of this initial 25 liters is water and how much is solvent. So in the initial 25, 40% of it is solvent. So 25 times 0.4 in my calculator to find 40%. Sure enough, that's 10 liters is solvent, okay? And that means that the remaining 15 liters is water. So what Lee wants to do is add a little bit more solvent so that it's 50-50, okay? Instead of there being a discrepancy between solvent and water, we want the percentages to be the same. So pretty simply, if I look at this problem, there's 10 liters of solvent, 15 liters of water. If I wanted it to be 50-50, I would add in, right, 5 liters of solvent, right? Because that would make it 15 liters of solvent, 15 liters of water. That's 50% each. That's how I know number 44 is G. Nothing too complicated about that. 45. For all x does not equal positive or negative y, x over x plus y plus y over x minus y equals, and you might be having, I don't know, flashbacks to some terrible algebra 2 lesson or something where you had to memorize some way to, simplify this or something. Even if you don't remember that, and I don't either, who cares? You don't need to. This is where picking numbers, that strategy comes into play. And I don't know if I've gone through a picking numbers problem yet in numbers 1 through 40. I probably did. I just can't quite remember. But this says for all x that does not equal positive or negative y, for every single option. So I'm going to say, okay, I'm going to make x equal 4, and I'm going to make y equal 2. I'm going to plug those values in here and see what number I get. I'm going to plug those same values into these 5 answer choices until I find a match. It's that simple. So I'm going to rewrite this initial equation with 4 for x and 2 for y. 4 over 4 plus 2 plus 2 over 4 minus 2. Okay, let's simplify that. 4 over 4 plus 2 is 4 over 6. That's 2/3 plus 2 over 4 minus 2, or 2 over 2 plus 1. This whole thing equals 1 and 2/3. Okay, or 1.666 if I'm doing it in a calculator, right? Well, now I need to find which of these answer choices over here is going to equal 1.666 when I put it in a calculator. Instead of writing them all out on the paper, I'm just going to do my calculator. Start with A, 1 over x minus y. Well, that'd be 1 over 4 minus 2. That's 1/2. It's not that. B says x plus y over x minus y. X plus y would be 4 plus 2, or 6 over 2. That's 3. So it's not B either. I guess I can cross these off as I go. So it's not either of those. C says x plus y over 2x. X plus y is 6 over 2 times 4 would be 8. So 6 over 8 is 3/4. Not C. D says x squared plus y squared. Well, x squared would be 16. Y squared is 4. That's 20. So it's not D either. I'm really hoping it turns out to be E, or I'm going to look stupid. X squared plus y squared. We just talked about that. That's 20, huh? So that's 20 over x squared minus y squared. That'd be 16 minus 4 is 20 over 12. If I put that in my calculator, if I want 20 divided by 12, sure enough, that equals 1.667, like I said, or 1 2/3. And that's how I know number 45 is E. 46. Mary, James, and Carlos sold quarter-page advertisements for the school yearbook. Mary sold twice as many as Carlos did, and James sold 3 times as many as Mary did. What fraction of these advertisements did Carlos sell? Well, he didn't sell a lot. Okay, he sold the least. So I'm going to pretend that Carlos sold 1. Okay, I'm picking numbers here, actually. I'm going to pretend that Carlos sold 1 and then figure out how many the others sold. So if Carlos sold 1, it says Mary sold twice as many as that. That means, so I'll put a C up here for Carlos. It means Mary sold 2. And it says that James sold 3 times as many as Mary. So that means that James sold 6. Okay? Again, the fact that they're quarter page, that doesn't matter. None of that stuff matters. Carlos sells 1. I'm just pretending. Mary sells 2. James sells 6. So what fraction did Carlos sell? Was 1 over 1 plus 2 plus 6 equals 1 over 9, or 1/9. That's how number 46 is F. Number 47. In a window display at a flower shop, there are 3 spots for 1 plant each. So I'm going to go ahead and draw this out. 1, 2, 3. There's the 3 spots. To fill these 3 spots, Emily has 6 plants to select from, each of a different type. Okay, so these 6 plants are all unique. Selecting from the 6 plants, Emily can make how many possible display arrangements with one plant in each spot? Note the positions of the unselected plants do not matter, and neither does this note. Okay, this is a math idea or principle called the fundamental counting principle, and it basically says this. In this first spot, we're going to have 6 plants to choose from, right? That means if I choose one of those 6 plants, in the next spot, I'm going to have 5 plants to choose from, right? And that means that in the third spot, after I've selected the first 2, I now have 4 plants to choose from. To determine the number of plants or possibilities for these 3 spots, I take these 3 numbers and I multiply them. 6 times 5 times 4. And if I put that in my calculator, I end up with 120, which is how I know that number 47 is D. And if you want to think about this or work on this, try it with smaller numbers. Like if I have, I don't know, 3 different, I don't know, ice creams to choose from or something, how many different ways can I arrange them? That sounded really stupid, but you get the point. It'd be 3 times 2 times 1 or 6 different ways. And that's just called the fundamental counting principle. If you need more of a lesson on that, then you can check that out in my book, The ACT Math System. I've got a bunch of good questions in there about this idea. Use the following information to answer questions 48 through 50. The quadratic function f and triangle MPQ are graphed in the standard xy coordinate plane below. Points M, N, and P are on F. Point Q is not on F. Okay, so then we have these 3 questions that are about this one graph. So this graph, again, is designed to scare you. It's supposed to just look scary and, make people waste time or something. It's not that bad. Okay, guys, what we've got here is a parabola that's graphed upside down. That's what F is. Okay, so it's going to keep going forever in this direction, whatever. And then we've got a triangle in there. Okay, so let's just take these questions. Let's tackle them one at a time and see what these questions look like. Number 48, in terms of A and B, what is the area in square coordinate units of triangle MPQ? Okay, we know the formula, hopefully, for the area of a triangle, and it's 1/2 the base times the height. So what we need to figure out is what the base is and what the height is. And this dash right here from M to P can be our base. And then, of course, the distance between that line and the x-axis, or all the way down, is going to be our height. So our base, M over here, is at 2a. P is at 6a. So our length there from M to P is 6a minus 2a, or 4a. Okay? So this is 1/2 of 4a. And some of you might be thinking, well, this triangle's upside down. How does this formula still apply? Well, if the triangle was flipped the other way, we could, I think what I'm trying to say is that we're used to seeing the base on the bottom or something, right? Instead of on the top. But it doesn't matter. Okay, if it's upside down or whatever, the same formula still applies. So 1/2 of 4a times the height. Our height is from down here at Q up to this point right here on MP. Well, that's a height of 5b, isn't it? So times 5b. So that's going to equal 1/2 of 4 times 5 is 20, right? And then a times b, ab. So that's 10ab, huh? And that's answer choice G. Okay, so far, so good. 49. Point M will remain fixed. Let me erase what I drew all over this graph up here so it's not so messy. Point M will remain fixed, and point Q will move to the right along the x-axis. As Q continues to move to the right, which of the following statements describes what will happen to the slope of MQ? Okay, so it's saying that, okay, here's MQ obviously on the graph right here. So as this point Q goes this way, right, and the slope, it keeps changing, right? It keeps going to look more and more like this and this and this. It says, which of the following is happening to the slope? Okay, well, it's definitely not staying the same. Okay, it's obviously changing. So it's not going to be C. So we got to figure out, is it increasing or decreasing? Okay, well, right now what we're looking at MQ is a negative slope. Okay, because slope, if you remember, is rise over run. So the rise means how tall it is, right? And the run is from left to right on the x-axis. So starting at M and going down to Q, it's going down, right? The rise is negative, right? It's a negative 5b. If we, let's just call it 5. Okay, let's leave out the variable to figure out the slope. So if it's rise over run right now, it's negative 5 over, if I go from M over to where Q is, it goes up, again, it goes from 2a to 4a, forget the a. So right now it's -5 over 2 basically, or -2.5 is the slope right now. Well, imagine if I take Q and I slide it all the way over to right here. Okay, let's call this 10a. Okay, so I'm sliding it all the way over there. What's happening to the slope of this? Well, the rise is staying the same. It's still going down on the y-axis the same. So this new slope is going to be something like -5 over, but instead of, a shift of 2a to 4a, it's 2a to 10a from what I just made up. So let's call that over 8. So now it's -5, 8. So it's going from a negative big slope still to a negative slope, but slightly smaller. So it's increasing. Okay, so A and B say it's decreasing. So it's not that. It's actually increasing. It's getting closer to 0. It's getting more positive. But look at the answer choices for D and E. It will increase but never be positive. E says it will increase and eventually be positive. That is not true. This slope will never be positive because a positive slope, right, looks like this. Whoops, it's a line that goes up like that. This line is never going to do that. Even if Q goes all the way out to like infinity way over here, like our line looks way like that, okay, it's never going to be positive because it's always, the rise is always negative. It's always going to be -5, if you will, over something. So maybe some big giant number over 1 billion, but that's still going to be a negative slope. Okay, so all that being said, this slope is always going to be increasing, but it's never going to be positive. And that's how the answer, sorry, I'm trying to erase this up at the same time. That's how the answer is actually D. It will increase, but it will never be positive. Number 50. And for this one, I need to erase this graph again. So let's erase all this stuff. Okay, number 50, it says, one of the following values is equal to f of 5a. Which one? Okay, so we're told that this quadratic, meaning this parabola, is called function f. F of 5a just means this. When I plug in 5a for x, if you will, what is the equivalent on the y-axis? That's what this means, right? That's why you always see, you always see things like this. F of x equals 2x plus 1 or something, and you figure out an x value, and you plug it in there for x, like f of 2 equals 2 times 2 plus 1 equals 5. And that tells you that, okay, when x is 2, the value of this function is 5. Or in other words, it goes up to 5 on the y-axis, okay? So in a very similar way here, f of 5a, we're just saying, okay, when x is 5a, what's the value of this function? In other words, what does this parabola go up to? So let's look at it on this graph up here. So we're looking for 5a. So let's go over 5a on the x-axis. So here's q at 4a, but here's 5a right here. So let's just go up and see where this meets f, or this quadratic, or this parabola. So I'm going up, 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 up. Okay, boom, right there. It meets it right here. Okay, this is the point where they meet. And if I go over on the y-axis, I see that it's boom, it's 8b. So going back to our answer choices, I need to find 8b. And that's how number 50 is K, 8b. 51. 12 jurors are needed for an upcoming trial. The diagram below illustrates a part of the process of jury selection. The 12 jurors will be selected from a jury pool of about 60 people. The court records show a trend that only 40% of the people who are summoned for jury duty actually appear, and of the people who appear, 1/3 are excused. If this same trend continues, how many people should be summoned to have as close as possible to 60 people in the jury pool? So we need this number down here to be 60. And the question is asking how many need to be summoned to make that number 60. Okay, let's look first at if we can get to this number right here, the appeared number, and then go from appeared to summoned. So this says, where is it? Right here, that of the people who appear, 1/3 are excused. Okay, so if 2/3 are in the jury pool and 1/3 are excused, right, that means that there's 30 people who are excused. Okay, so that's a total of 90 who appear. Okay, because if 90 appear, 1/3 are excused, that's 30, because there's 60 in the jury pool. Okay, so now we know that 90 appear. This sentence here says, the court records show a trend that only 40% of the people who are summoned for jury duty actually appear. So this number of 90 is 40% of some bigger number. So we need to set up an equation to figure out what that bigger number is, because that's how many are summoned. Okay, so 40% of the summoned actually up here. Let's set up an equation. I'm going to zoom in a little bit right here. So 90 is 40% of some bigger number. Okay, 90 equals 0.4 or 40% of x, which is our bigger number, which is summon. I'm going to call that x. So once we figure out x, that's going to tell us what we need to know, because they need to know how many to summon so that 90 appear, so that 60 end up in the jury pool. Okay, well, this is relatively simple. We divide both sides by 0.4, and that's going to tell us what x equals. So x is going to equal 90 divided by 0.4. Put that in your calculator. 90 divided by 0.4 equals, so now x, come on, x equals 225. Sorry, this is messing up a little bit, but 225. That's how the answer number 51 is D. 225 people need to be summoned so that 60 end up in the jury pool. Number 52. What is the 275th digit after the decimal point in the repeating decimal 0.6295? So the ACT, this is a classic ACT question. They can ask in lots of different ways. Sometimes they'll say something like, what is the 340th digit after the decimal point in the repeating decimal or whatever after the fraction 3/11ths? I don't know, I made that up, okay, or whatever. But the moral of the story is you've got some repeating pattern of decimals. How do you figure out the 275th digit? Okay, it's not as hard as it might seem. You don't have to write this out, obviously, to the 270th digit. That would be a waste of time. What we're looking at here is a repeating pattern of 4 decimals, 6, 2, 9, and 5. What that means is that 5 is always going to be the 4th digit after the decimal point, right? It's going to be the 8th digit, the 12th digit after the decimal, the 16th, the 20th. Okay, do you see what I'm trying to say here? What I'm trying to say here is that if a number is divisible by 4, it's going to be a 5, right? Because 5 is the 4th digit, the 8th, the 12th, the 16th, the 20th. Well, if it's the 20th, then guess what? It's the 200th, it's the 220th, it's the 240th, it's the 260th, it's the 264th, 268th, 272nd digit after the decimal point. Okay, so if the 5, again, that was just my way of counting by 4s and getting up to 200, close to 275, huh? So if 5 is the 272nd digit after the decimal point, well, that means that 6 is the 273rd, 2 is the 274th, and 9 is the 275th. And that's how the answer to number 52 is K, 9. 53. Given that f of x equals x squared minus 4 and g of x equals x plus 3, what are all the values of x for which f of g of x equals 0? Okay, the first thing we want to do before we worry about what are the values that make this equal 0 is we've got to simplify this down. Okay, we've got f of x and g of x. F of g of x just means this. You take, okay, let's say this said f of 2 equals x squared minus 4. Well, you would know to take 2 and plug it in there for x, okay? And we have to do the exact same thing here, but instead of plugging in a number like 2, we plug in g of x. Well, why? Because this is asking for f of g of x, okay? So f of g of x means we take g of x and plug it in for x in the original f function, so that equals x squared minus 4. Okay, well, I'm plugging in x plus 3 anywhere there's an x over here. So this is x plus 3 squared, or x plus 3 times x plus 3 minus 4. That's not a very good looking 4. Okay, minus 4. So I'm going to FOIL over here and figure out what this simplifies down to. This is going to equal x times x, which is x squared, x times 3, which is plus 3x. Let's see, 3 times x, which is plus 3x, and 3 times 3, which is plus 9 minus 4, and that equals x squared plus 6x plus 5. Okay, now what we've done here is we've simplified down these functions and all this stuff to a quadratic or to a parabola. And we said before that a parabola or a shape like this, its solutions are going to be where it crosses the x-axis. Now, the way that this is written, let me erase some of this stuff up here. The way this is written, it says, what are all the values of x for which f of g of x equals 0? So setting this equal to 0, this is another way of saying what are its solutions, or what are the values for x, which make this parabola cross the x-axis at y equals 0. Okay, or just where does this parabola cross the x-axis? Okay, from here, there are two different ways that we could solve this problem. One of them is going to be to graph. I think we did that earlier before with one of those problems where we graphed it. I think it was like 24x squared or something. I forget what exact number that was. But we could graph this. So if you go to your graphing calculator, you're going to hit y equals, you can clear away what was there before, hit that xt theta n button for x. So x, hit the x squared, plus 6 times x, that's that xt theta n button again, plus 5, top right-hand corner, hit graph, and hopefully if you're zoomed correctly, you're going to see a parabola show up on your screen. If the zoom is off, like if you're way zoomed in or way zoomed out or something, and it's kind of hard to figure out where this parabola is crossing over the x-axis, hit the zoom button in the top middle and go down to zoom standard. For me on my calculator, it's the 6th option, hit enter, and that'll be kind of a standard view. So here's what I'm looking at when I graph this in my graphing calculator. Here's my XY coordinate plane, 1, 2, 3, 4, 5, like that. I see a parabola that comes down over 5 and it goes back up at 1, something like that. Sorry, that's an ugly parabola, but that already tells me that the answer here is going to be A. Even if you can't see that it crosses exactly over x equals -5 or x equals -1, you can definitely see that our two options are two negative numbers, okay, two negative x values that cross over somewhere near x equals -1 and somewhere near x equals -5. And there's only one answer choice that's even in that ballpark, and that's A. It's the only option that has two negative numbers. Another thing we could do is we could factor this trinomial and then set our two values equal to 0. So why don't I do that now? Let me erase this up here and do it up here. So we've got x squared plus 6x plus 5. So what we need to factor this, I'm gonna factor it up here into its two binomials. So you'll see what I'm talking about. I'm gonna set that equal to 0. I need two numbers that multiply to give me +5, two numbers that that add then also to give me +6. So x plus 5 and x plus 1 is gonna work. And let me explain what I just did there. So I need two numbers that multiply to give me +5. There's only 5 and 1, right? And the question is, do those options add up to +6? So I guess -5 and -1 would also work, but that would add up to -6. But 5 and 1 add up to this +6 term in the middle. So when I set up my binomials up like this, x plus 5 and x plus 1, set them equal to 0. To figure out the two options now, or the two values where this parabola crosses the x-axis, I split these, and I set each of them individually equal to 0. So x plus 5 equals 0, and x plus 1 equals 0. Solve for x, subtract 5 from both sides, x equals -5. Subtract 1 from both sides over here, x equals -1. Same thing, -5 and -1. No matter how you do it, number 53 is going to be A. 54. Given that p is a positive number and n is a negative number, and the absolute value of p is greater than the absolute value of n, which of the following expressions has the greatest value? So this, to me, immediately is screaming picking numbers. So in my book, The ACT System or the ACT Math System, this kind of a question would belong in a category that I call logical thinking with variables. And picking numbers and eliminating wrong answer choices in that kind of a way is the best way to solve these kinds of problems often. So p is a positive number, n is negative, and the absolute value of p is greater than the absolute value of n. Absolute value, of course, just means the distance something is from 0. It's always a positive number. So let's pretend that p equals 3. Let's make it a little bigger for fun. Okay, p equals 10, and let's say that n equals -5, okay? Because then the absolute value of n, right, in that case is going to be a +5, and this is still going to work because the absolute value of p is going to be 10, absolute value of n is going to be 5, 10 is greater than 5, so that's going to work. So now what I want to do is plug 10 and 5 for p and n respectively into these 5 answer choices and see, okay, which of these is going to equal, which of these is going to be the greatest value, which is what the question is asking of us, right? So which of the following expression has the greatest value? So I'm sorry I erased it, but p equals 10, n equals -5. Let's go one at a time and figure it out. So this is going to equal the absolute value of p minus n. So 10 minus a -5, so it's 15 over p, 15 over 10, which is just going to equal 1.5, right? Which is 1.5. Okay, so that's not too big. Let's see what else we got. So p over n, let's see, p minus n, that's also -15 over n, which is -5. Okay, so now that's going to be, right, -5 into 15, absolute value. So that's going to be 3. Okay, so that's the biggest so far. H, P plus N, so that's 10 plus a -5, is just the absolute value of 5 over P minus N, 5 over 15. Okay, that's a fraction, so it's not going to be H. So far it's not F, it's not H. J, P plus N again, so we got 5 on the top, over P over 10, that's half, so it's not J either. K is P plus N again, which is just the absolute value of 5 over N, which is -5. That's 1. Okay, so that's how I know the answer is G, 3. Again, don't let this be something conceptual that just lives in your head. Make it real by picking numbers like we did over here, going through the options. It doesn't take too long. That's how I know number 54 is G. 55. If I equals the square root of -1, then I plus I squared plus I cubed over I cubed plus I to the 4th plus I to the 5th equals what? Okay, so this question is designed to be scary and to look scary and to seem like the kind of thing you can never get right because maybe you have some friend who one time uses I in their classes and you've seen it before and it freaks you out. Okay, the imaginary number I doesn't need to be scary, especially on the ACT. So they're going to introduce this kind of question. This is a classic ACT question, either by saying I equals the square root of -1, like they do here, or they're going to say I squared equals -1. And this variation of it is the key. These two are the same, but this variation is the key because it just means anywhere you see an I squared term in these things, you can replace it with a -1. So that's what we need to do here very carefully and just reduce this down. As you can see, it's ultimately going to reduce down to some number, okay? And that's what we've kind of got to figure out. So I'm going to go through each of these terms actually one at a time because we have to eliminate every I. So I'm going to put -1 where there's an I. If I can replace it with an I squared, I'm going to put a -1 there. Sorry, did I say -1? I meant for I, like this one, I'm going to put a square root of -1 for any term with a squared in it, which includes all these. I'm going to put a -1, as you'll see. Okay, let's just go through it. Okay. So let's simplify this as best we can. Let's start with this I right here. Well, the best way that I can reduce that is just by calling it the square root of -1 for now, okay? Plus I squared, I know what that equals. It equals -1. So plus a -1, I'm going to be really careful here, plus an I cubed. Okay, I cubed is the same thing as I squared times I. So what I need to put there is plus -1 times the square root of -1. Okay, so that's just how we got to leave that right there. All right. Over, sorry, this isn't working too well. Okay, over, whatever. Over I cubed again. We know what that is. So that's, I'm going to zoom in a little. So that's, let's see, -1 times the square root of -1. I to the 4th. Okay, that's just I squared, this one right here. That's just I squared times I squared, which is -1 times -1, which is +1. So I'm just going to say +1. And then lastly, plus I to the 5th. Okay, that's I squared times I, which is +1. So plus 1 times the square root of -1. Okay, so that's a lot, but let's see how we can reduce this down as best as possible. Let's see if I can find some room to do that right here. Okay, so starting here, we've got the square root of -1 starting on top. What is going on here? Square root of -1. Okay, maybe if I zoom out, it's better. Okay, square root of -1 minus 1. Okay, and then we have plus -1 times the square root of -1. Okay, in other words, minus the square root of -1. Okay, over -1. So now I'm down here. -1 times the square root of -1. So that's negative square root of -1. Come on. Plus 1. And then plus 1 times the square root of -1. So just plus the square root of -1. Okay, so that's a lot. And hopefully you're following me, at least in general. But what I have here now is this. Look, on top, I've got a square root of -1 and a negative square root of -1. These cancel out. Okay, cancel, cancel. And on the bottom, I've got a negative square root of -1 and a positive square root of -1. Because guess what? Those also cancel. So cancel, cancel. And that leaves me with -1/1, which is -1. And that's how number 55 is B, -1. Okay, now if you're not a fan of the way that I just did that there, it's also possible to put this question in your calculator there is an I option. So like if you look at your calculator, let's see, where is the letter I? You probably already found it before me. Oh, there it is. It's second period. So at the very bottom, the decimal point, second decimal point is the letter I. So you can put this whole thing in your calculator, okay, with that letter I down there. This is probably the second biggest advantage to having a graphing calculator. The first is graphing parabolas for sure, like we've done a couple of times. The second one is in these kinds of problems here with the letter I. You can plug this whole thing in your calculator and hit equals, and it'll calculate it all up and spit out the number -1. So 55, for all those reasons, is B, -1. Number 56, in one of the following graphs in the standard XY coordinate plane, the solution set to the system of inequalities below is shown shaded. Which one? And then we have these 5 options of these different graphs with these circles and lines and shades and all this kinds of stuff. Okay, the first thing we need to know to get this question correct is that these inequalities, so if I zoom in a little bit, these inequality symbols right here, for the most part, can be treated like equal signs for simplifying. And what I mean by that is this. So this equation here is one of a line, right? If you think of like the less than or equal to that I circled there as an equal sign, you can see that that's going to be a line. And hopefully, or maybe you know that this second one right here, we have an x squared and a y squared term. If that greater than sign that's in this second one was an equal sign, you would probably be able to see that that's the equation of a circle. That being said, what I want to do is simplify these two expressions. Let me erase some of this stuff. I'm going to simplify these two expressions down into more of a, well, form that we're used to, so we can see how they're supposed to be graphed. I will say that it would be much easier in this question if we had these XY coordinate planes and all the answer choices, if we knew some of the coordinates. So like, for example, if we knew that this point right here, whoops, that was the eraser. If we knew this point right here and J was like 2, 2 or something, then, we could plug that into our options up there and see which one satisfies or whatever. But that's not an option for us because none of these have, well, any points marked. So we're going to have to do it the old-fashioned way. Okay, so I'm going to simplify these two expressions. I'm going to start with the top one, and I'm going to get it into slope-intercept form, which is y equals mx plus b. So I need to isolate the y on the left-hand side. So the first thing I'm going to do is subtract x from both sides, and that would leave me with 2y is less than or equal to negative x plus 6. That's where I am so far. And then if I divide both sides by 2, so divide everything by 2, right? Then I'm going to end up with y is less than or equal to negative 1/2 x plus 3. You might remember with inequalities that there are situations where you flip the sign from less than or equal to greater than or equal to, or maybe from greater than to less than. That would only be the case if you manipulate both sides by a negative. So what I mean is this. So in the second step, I divided everything by 2. Remember that? If I divided everything by -2, I would flip that sign from less than or equal to greater than or equal to. But that doesn't matter for this particular question. This is our simplified form right here. So here's what I know about this. The line, so you see each of these answer choice options as a line, right? So F, J, G, K, H, like they've all got some kind of line like that. 4 of them it's going down, 1 of them it's going up. But what I know about this line is that it has a slope of negative 1/2, because this is slope-intercept form, right? Y equals mx plus b, where m is the slope and b is the y-intercept, or where it crosses the y-axis. So I know this slope is going to have, this line is going to have a slope of negative 1/2, go down 1, go over 2. So in other words, it's not going to be a positive slope. So letter J, the line goes up. That's a positive slope. So I already know it's not going to be J, okay? I can also eliminate G based on this as well. And the reason for that is because G has this dotted line. Do you see that? That dotted line indicates that the points that to satisfy this inequality, it's basically saying they can't be on the line. That would only be the case if this inequality that we simplified here earlier, if it was y is less than negative 1/2 x plus 3, but we know it's less than or equal to, right? It's got that equal to little dash under the bottom. So in other words, the points can be on the line. So I know it's not G as well, okay? So far I'm able to eliminate J and G based on, actually I'm able to eliminate one more. Just kidding. Okay, there's one more we can eliminate, and that's answer choice H. And the reason I can eliminate answer choice H already at this point is because the points for y, right, because it's y right here, the points that are going to satisfy this one line are going to be beneath the line. Well, why? Because it's y is less than or equal to negative 1/2 x plus 3. If it was y is greater than or equal to negative 1/2 x plus 3, then yeah, as h does, I would shade in all these points above the line. But that's not the case. It's y is less than or equal to negative 1/2 x plus 3. So h has also got to go. So that leaves us with either f or k. So I would say this, if you're strapped for time, then you could be making educational guesses here at the very end of a test. But we want to solve this problem if we can. So let's erase all this stuff. Hopefully I'm not erasing anything too important, but I feel like it's just too messy and I need some more room to work with this circle one. Okay, we've eliminated which ones? J, G, I'm going to scratch them off. J, G, and H. Okay, it leaves us with F and K. Okay, the second inequality where it says 3x squared is greater than 12 minus 3y squared, this is the formula of a circle. So if I add 3y squared to both sides, then I'm going to end up with an inequality that looks like this. 3x squared plus 3y squared is greater than 12. Maybe you notice right now that this can also be simplified. If I divide each term by 3, right? So divide by 3, divided by 3, divided by 3, then I'm going to end up with this. X squared plus y squared is greater than 4. Okay, the formula for a circle, generally speaking, looks like this. X minus h squared plus y minus k squared equals the radius squared. That's the formula for a circle. But when there's no h and k, like right here, there's, you see this format where it's like x minus h. hk refers to the center of the circle. So when it's just x squared plus y squared, like we see here, I know that this circle is centered at the origin. Just as a side note, f and k, both these circles are centered at the origin. So that matches up. Okay. But the way that this is written, x squared plus y squared is greater than 4. If we pretend that greater than is an equal sign for now, x squared plus y squared equals 4. The 4 on the right-hand side is the radius squared, okay? And here's the last step for me to get this problem correct. Because f and k, they both have the shaded portion outside of the circle, which for me tells me I don't really need to worry about that, like trying to figure out, is the shaded portions outside of the circle or inside of the circle? They're both outside of the circle. So the radius squared part of the right-hand side is what's going to kind of drive this home. Okay, this number right here then, where did that eraser come from? It's greater than 4. Okay, this number right here is not the radius, it's the radius squared. That tells me that this circle in this equation has a radius of 2, okay? And that's the last point that we need to know to get this question correct. And like, well, how? We don't see any measures in this problem. We don't know the radius of f, the circle there, or k. It doesn't tell us. But here is what we know. This point right here, golly, I keep hitting the eraser on accident. This point right here is the y-intercept of the line that we found previously. And if you remember, the y-intercept of that line was 3. Okay? So if that has a y-intercept of 3, because remember, I erased it because I'm bad. It was y is greater, geez, I keep messing up. Okay, y is less than or equal to negative 1/2 x plus 3. Remember that? And so this plus 3 is the y-intercept. This line crosses right there at y equals 3. That's the y-intercept. That tells me that the circle, the radius of it, is going to be less than 3. So this one over here, the circle goes way bigger than 3, doesn't it? Because if 3 is right here, this circle is purporting a radius of 4 or so. But we know the radius is 2, not 4. That's how I know the answer here is K. And there might be other ways to solve this problem, but for now, that's going to have to be good enough. As a side note, the real paper ACT doesn't have problems over here in this column. They give you all this space to write and solve your math problems. If you're taking it on paper, or if you have scratch paper for the online one, then of course you have all this room. I wish they'd do that in this practice test, but I guess they're trying to save on printing costs or something. If they're printing these up for schools, I don't know. 57. Let A, B, C, and D be real numbers. Given that AC equals 1, B plus C over D is undefined, and ABC equals D, which of the following must be true? Okay, the first clue that we have in this question, well, there's lots of clues. Obviously, there's 3 of them. But I want to look right here at this part. This is the part that caught my eye first. B plus C over D is undefined. This is the only of these three clues that tells us something definitive, okay? And the thing that it tells us that's definitive is that D equals 0, okay? That's what it means for an equation or a fraction to be undefined, is if you have a real number that you're dividing by 0. So that's a great place to start, that D equals 0. And if you look right here, what am I doing? If you look right here, we get another clue. It says ABC equals D. Okay, well, that clue tells us that something, some variable here, A, B, or C, one of them has to equal 0. Okay, so either A equals 0, B equals 0, C equals 0, or all of them or two of them. Something there has to equal 0 if we're going to set those three variables multiplied by each other to equal D. Well, that's where the last clue comes into play. So this clue up here says AC equals 1. And what that tells us is that A cannot equal 0 and C cannot equal 0. Because if A or C equals 0, there's no way, obviously, that A times C is going to equal 1. It's always going to equal 0. So if D equals 0, if A or B or C have to equal 0, but if A and C can't equal 0, that leaves us with one last thing or one last truth that we can figure out, and that's that B has to equal 0. There's no other option given all these things, okay? For that reason, I know 57 is D, B equals 0. Okay, 58. A cosine function is shown in the standard xy coordinate plane below. You see it there. One of the following equations represents this function. Which one? And then you see there f, g, h, j, k. So this is a classic ACT math problem. I wouldn't say a question like this with a graph of sine or cosine is guaranteed on your next ACT math test, but it is very likely that you would have one. So if this is a problem, check out my ACT math book, the ACT math system. I have a lesson in there in what I call step 5 on math that's good to know, which is all about, well, waves, the terminology of waves, and the graphs of sine and cosine. Okay. Normally, the graph of cosine looks like this. If I were to draw it out a little bit, it goes up to 1 up here, goes down to -1 here. And if you've never seen this before, on this graph here, we've got like this pi over 2. This is referring to a way to measure angles called radians. And even if you've never used them in your math class, we can know some basic things about them, okay? So normally a cosine graph does this. Well, let me chart out the x-axis here. So we'll call this pi over 2. We'll call this pi. We'll call this 3 pi over 2. We'll call this 4 pi. Normally, a cosine graph does this. It starts at 1. Maybe I'll pick a different color to be fancy. It starts at 1, and it goes like this. It goes down there, up here, like that. Okay? On this graph, pi is equivalent to 180 degrees. Okay? So, pi over 2 is equivalent to 90 degrees, if you will. 3 pi over 2 is equivalent to 270 degrees. And then, of course, 4 pi is equivalent to 360 degrees or 0 degrees, okay? That's another way to think about it. You can kind of play with this and kind of see what I'm talking about. If you go to your calculator and you type in the cosine of 0 degrees, you're going to get a value of 1, okay? Or if you type into your calculator the cosine of 270, you're going to get a value of 0, okay? And then all the other values between those values are going to be somewhere between 1 or -1. Okay, so if you type in the cosine of 180 degrees, you're going to get, right here at -1. Okay, and everything else is going to be in between. And that's why it makes this wave pattern, okay? So for whatever reason, we're using radians in these graphs of sine and cosine. We're used to that. And so instead of putting degrees, we put pi, okay? But that's enough about that. So here's what we need to do to get this problem correct. We notice on this graph up here that this function or this graph, this wave, is being stretched very tall, isn't it? So here's 1. This is where cosine should usually start. Okay, if I were to draw what cosine should usually look like on here, it would start at 1, right? It would go down through pi over 2, it would go down to -1, it would come up, or what, I think that's fairly accurate. It would do something like that, huh? But instead, it goes all the way up here to 3. What that tells me immediately is that this whole cosine function is being multiplied by 3. Okay, so in other words, if you go into your calculator and type in the cosine of 0 degrees, you're going to get 1. If you multiply by 3, you're going to get, 3. And so the first point's going to be way up there. So that eliminates F and G because I know the answer is going to be H, J, or K because these are being multiplied by 3. Secondly, another thing to notice about this, well, obviously, if you look at the answer choices, H, J, or K, the angles inside are now being manipulated. We know it's being multiplied by 3, but we have to figure out how is the angle within the parentheses that we're applying the function cosine to, how is it being manipulated? And it might seem, like this graph, if you can't really tell, is being squished. It's kind of like usually, like we said below, cosine looks like this, but this graph is like this. Like it's being squished in like an accordion being pushed together. And so that might make you think, okay, well, if it's being pushed together like that, we must be making something smaller. And so to make things smaller, you divide. So it must be H or J. And that's not bad thinking. No, that's good thinking. The problem is that it's not really true. Okay. So look right here at this point up on this graph way up here. Okay, in the original equation. This point is over, right? It is over right here at pi. Okay. So compare that to down here at this normal graph of cosine. Normally, the cosine wave curve is going to peak again at 4 pi, okay? In other words, at 360 degrees, okay? So if I take my angle of 180 degrees and multiply it by 2, that gives me 360 degrees, okay? So in other words, here's what I'm noticing about this original function up here, is that it's peaking at 180, right? It's going back up to 1 at 180. Well, you can't, or sorry, up to 3 in this case, but you can't get that value of cosine from 180 degrees normally. Normally, it'd be a negative, but if you take that value of 180 degrees, multiply it by 2, now it's 360. Find the cosine of that, you're going to get a peak, usually at 1, here in this case 3. And that's how I know that these angles within are being multiplied to be bigger. So that's how I know the answer here is K. It's Y equals 3 times the cosine of 2x. So it might just help you to remember something like this, that the angles within, if they're being divided, then this graphs of sine and cosine are going to stretch out like that, okay? If this is normal, they're going to be stretched out. If it's being multiplied, if the angle's being multiplied to be bigger, it's going to pinch in kind of like that, okay? So this is multiplied. I'm talking about the angles within the cosine parentheses, and this is divide, okay? So moving on to the next one. Number 59, the figure below shows a flying kite. At a certain moment, the kite string forms an angle of elevation of 75 degrees from point A on the ground. At the same moment, the angle of elevation of the kite at point B, 240 feet from A on level ground, is 45 degrees. What is the length in feet of the string? Well, this question would be, well, much easier if we were dealing with a right triangle, Because when you have a right triangle, you have a 90-degree angle. Makes it very simple to use trig functions like sine, cosine, and tangent to find missing sides or missing angles or that kind of a thing. The problem here is that, of course, we don't have a 90-degree triangle. We have something different. So we have one angle that's 75 degrees, one angle that's 45 degrees. It's going to come into play. So I might as well find this missing angle up here, which would be 180 degrees, right? That's how many degrees are in a triangle, right? So 180 minus 75 minus 45 is going to end up being 60 degrees. So we have this triangle instead, and we only know the length of one side. So sine, cosine, tangent, Pythagorean theorem, this kind of classic ways of finding missing sides and stuff is not going to be applicable. Instead, at least for me, the most immediate way to know how to find this missing side is with what's called the law of sines. And there might be other ways too, but the law of sines is really not too difficult to remember. It just means that if you take the sine of an angle and put it over the length of the opposite side, that's equivalent to the sine of any other angle over its opposite side. So I think in its form, it always looks something like this. So pardon me if I get some letter wrong or something. It's always something like the sine of, alpha over side length A equals the sine of, I don't know, beta over, or some little b, whatever, over long side B, something like that, okay? And so we can use this law or this rule to find this missing side, which is the length of the string. Okay. So the reason I define the 60-degree angle is because the only side that we know is the one that's opposite this 60-degree angle. So plugging what we know into the law of sines, let's start with well, the most basic thing we know, which is that the sine of 60 degrees over 240, I guess that's one equivalent pair, if you will. Sine of 60, its opposite is 240. That's going to equal the sine of 45 degrees over what we're missing over here, huh? Because here's 45 degrees and its opposite, right, is the length of the string. So let's just call it x to keep it simple. Okay, so we'll just call the length of the string x. To keep it simple, well, now we have a simple algebraic question instead where we can cross multiply and solve for x. Okay, so if I cross multiply over here, I'm going to get that the sine of 45 times 240 is going to equal the sine of 60 times x. And then if I divide both sides by the sine of 60, I've now solved it for x. Okay, whoops, 60. So these cancel over here. And now I get the sine of 45 times 240 divided by the sine of 60. I'm going to put all that in my calculator just in one fell swoop. So sine of 45 times 240, that equals 169.7. Divide that by the sine of 60, and that equals, so x equals the length of the string, 195.96 if I'm rounding, okay? And there's going to be some rounding error in there probably. So if I look at the answer choices, well, if I did this math correctly, it's not going to be C or D or E. Those are way too far off. It's going to be either A or B, where you've got this number multiplied by the square root of some other number, okay? And these square roots of some other number that they're being multiplied by here tells me that there's probably another way to solve this question that I'm forgetting or leaving off, but to me, this would be the simplest or fastest way, although there might be some other kind of way that I'm just not familiar with at the moment. But 60 times the square root of 3 is going to be something like, I don't know, 90 or so, something like that. So instead, what we want to try in our calculator is this one, 80 times the square root of 6. So I'm going to put that in my calculator. Usually I start with things like the square root of 6, put that in my calculator, that's 2.44 times 80. And sure enough, that equals in my calculator 195.96. So that's on number 59 is B. And number 60, if a publisher charges $15 for the first copy of a book that is ordered and $12 for each additional copy, which of the following expressions represents the cost of Y books? Okay, I think the easiest mistake to make on this problem would be to say something like, oh, okay, well, if we order Y books, that's 12 times Y, and then plus $15 for the first book you order. So I'm going to guess that probably if students are getting this question wrong, they're probably putting G most often. But let's imagine this. Let's imagine that every single book costs $12. Okay, because we know that each book costs at least $12. The first one costs $15, and all the rest cost $12. So we know each book costs at least $12. Well, if each book costs $12 and we order Y books, then we would say, well, that would be 12 times Y. Because 12 times Y, if we order 10 books and they cost $12 each, well, that's going to be $120. Or if we order 100 books and they cost $12 each, that's going to be $1,200 that we're spending. The only hiccup in this problem is that the first book costs 15, not 12. Okay? So we're going to, no matter how many books we order, okay, we're going to be paying $12 per book, except the first one's going to cost an additional $3, not an additional 15, an additional 3. The first one will cost an additional $3 no matter what, and then all the rest will only cost 12. So 12Y plus that extra $3 for the first one. No, there's no variable that goes on the number 3. There's no Y or any other kind of thing that goes attached to it. It's just an extra $3. So think of it like this. If I order one book, right, the first book's going to cost 15. So if Y is 1, if I plug that in there for Y, that's 12 plus 3 of 15. If Y is 3, let's say we order 3 books. If I'm thinking about it in my head, I'm going to pay 15 and
12 and 12. That's gonna be $39 if I buy 3 books. Well, let's plug in y equals 3. Well, it's gonna be 12 times 3 plus 3, which is 36, plus 3, which is 39. So no matter what y equals, that's gonna be the proper amount. That's how I know number 60 is F, 12y plus 3. Okay, well, if you've stuck with me this far, then I don't know, you're pretty dedicated to this ACT math test. So hopefully these explanations are very helpful to you. So you might be listening to this just at the end of the video about numbers 41 through 60, but my plan is to put this all together in one massive test that goes through these 60 problems. But if you're planning on taking the new ACT with the 45 math problems with the 50 minutes, just be aware if it's shorter, that doesn't mean it's easier. I've already taken one ACT practice math test from the ACT itself in this new format, and I'm just telling you it's not easier. It's the same level of difficulty with just less questions, and maybe they give you a bonus 5 minutes, but to me that just kind of gives them the leeway or the opportunity to make the questions a little bit harder because they need this to come out on a bell curve anyway. So still, I think the best type of preparation for you is not just to take a practice test like this one, but to take it and then dive into the questions you get wrong so you can come to a greater understanding of what you missed and why and how to fix it next time. And if you do that over 3 or 4 ACT math tests that have been given in the past, you're going to encounter the vast majority of ACT math problems that have ever been given. Okay, at least their types or categories. So do that. Hopefully this video is helpful to you to that end. And thanks for participating. God bless you.